All right, so we've spent a couple of days on the fundamental theorem of calculus, what it is, how to use it with our integrals. So today we're going to look at interpreting it, like making sure that we understand what it even means and whatnot. So let's look at this. The first fundamental theorem of calculus could also be called the total change theorem. If you are given the rate of change of a function, you can find the accumulated change in the function f of x. So remember that whole accumulated change, that's why we have that area under the curve idea there. All right, so W of t is the rate at which a baby gains weight after birth, where W is measured in pounds per month, and t is measured in months since the baby was born. Interpret each of the following indicating the correct units. So we have an integral from 0 to 1 of W of t dt, and we have a value for that. So what does this, if I'm going to integrate W of t dt from 0 to, or just if I'm going to integrate that in general, what are the units going to look like on that? Think of it that way. Pounds, because if I'm doing an integral, that's like our area under the curve, right? And we're going to take W of t, which is pounds per month, times dt, that's the dt, the change in t is months. So you're taking pounds per month times months, and you end up with pounds. Does that make sense? So that means this represents pounds. We can put pounds on there, right? And this is pounds. That's our units on there, right? So 0 to 1, what does that represent? Over a month, yeah. So the 0 and the 1 is just the 1 month, right? So this is the amount of weight, because it says baby gains after birth. So this is the amount of weight we gain after 1 month. And since it's negative, do we really lose it? No. Okay, so we can say, so our interpretation can be that a baby loses 0.127 pounds in the first month. Something like that. So it's not over any month. It's from 0 to 1 month, so it's in the first month of its life. Does that make sense? So this means a baby does what? Gains. A baby gains how much? Yeah, gains 9.7 pounds in the first 12 months. I honestly don't know the answer to that question. I would think yes, but since we're talking in months, our answer I feel like maybe should be in months. But since that is kind of a universal daily language thing, I would think a year would be okay. But sorry, I can't really give you that. I would take it. Whether or not AP would take it, that's the whole different thing. Okay. Anybody else? Good? All right, so let's look at this. If W prime of t is the rate of growth, a child pounds per year, what does this integral represent? So first of all, what would the units be on this? Pounds, right? The 5 and the 10 represent what? Years, okay? Because it says in pounds per year, so the change, the dt, the change in time, is going to have to be in years. So this is pounds per year times years. That gives me pounds, right? So we can say, let's see, this would be the number of pounds a child gains when? So we would say from t equals 5 years to t equals 10 years. And I think saying what you said would probably be fine from 5 to 10 years old. Kind of same thing. Just a lot of what we put, we'll usually put like a T equals type of thing on there. So that's your accumulation. They accumulated that amount of weight from 5 to 10 years, right? Okay, so then we have the oil leaks from a tank at a rate of R of T gallons per minute. So that means when we actually integrate, we'll be in gallons, and this would be in minutes, right? So we would say the number of gallons then leaked out, or leaked from, either way. A tank, and I would say again from like T equals 0 minutes to T equals 120 minutes. Well, it's not over any 2-hour period, it's over the first 2-hour period. So I think if you set it that way, you should be fine. Kind of like this. This isn't from in any 5-year period, it's in that second, maybe say second 5-year period, something like that. That's a good question. All right, so then we have a honeybee population, starts with 100 bees and increases at a rate of N prime of T bees per week. So our rate is bees per week, which means time is in week. So when we get this, this will be bees, right? That'll be our units. Okay, so the number of bees, is it the number of bees added to the population? What represents the number of bees added to the population? That's this part. That's the accumulation, right? This is how many are added. This is how many we started with. So when we add them together, this is when we get our snapshot, right? Remember the difference between having an accumulation and having a snapshot? So it's the number of bees, let's see, in the population, which is the strange wording, but I'm just kind of rewording what they have, in the population at T equals 15 weeks. Do you see the difference there? It's not how many we gained, because these have been how much we gained, because it's just the integral, that's your accumulation. If you're going to add or subtract something, that's what gives you the snapshot. Remember the difference between like the at and from type of situations there? Does that make sense? We good? Because it's important that we understand the difference. Okay. All right, so here it is in context. Let's see what this says. Water is pumped into a tank at a rate of R of T equals 30, blah, 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 gallons per minute, where T is the number of minutes since the pump was turned on. Set up, but, and solve. I really should say set up, but don't solve. But don't solve. And we really could solve it. It's just we won't get the calculators and it's fine. The equation that would represent the amount of water in gallons in the tank after 20 minutes. It does not say the amount of water added to the tank. It says how much water is in the tank. Do you see the difference there? So if that means I'm going to integrate this. If I'm going to integrate R of T dt, this is what I get after I take the derivative, right? So what does R of T look like before I take the derivative? Remember what it looks like? Like if I have R prime, R double prime, what is this going to be? Capital R, big R, right? So that means that I know, let's see, it contained 800 gallons before it was turned on. So R of 0, when time equals 0, I have 800 gallons. Does that make sense? I started with 800 gallons, that's R of 0, capital R of 0. I want capital R, or I'm going to need capital R of 20. Right? Does that make sense? That's what I'm looking for. Or I'm going to use that, rather. Okay, so that means R of 20, how much water do I have at 20 minutes? That's going to equal capital R of 0. And then I'm either going to add or subtract an integral. These two numbers here are the limits of integration, so I put 0 here and 20 here. Since 0 is at the bottom, I'm adding. And then it is R prime, no, it's not. It's R of t dt. And this is why it's the amount of water at that time. It's the amount that's accumulated plus what we started with. That's how we get that. And so if I was going to actually put this in the calculator, which we're not going to bother doing that right now, we can find R of 20 equal, why are they knocking?
Congratulations, I picked you as my star teacher.
Aww. All right, so I'm going to back up on this question for those that just came in. All right, so were those two in there too? Did you see them? Okay. I don't know. I'm going to probably just skip it my class. All right. So again, so what we're doing right here is almost exactly what we did on Friday. The context part of it, it's easy. But like this particular question is almost identical to what we did. The stuff above it was a little bit more theory-ish, but like I said, I'll go back to that for y'all. All right, so water's pumped into a tank at this rate, gallons per minute, where T is the number of minutes since the pump was turned on. Set up, but don't solve the equation that would represent the amount of water in gallons in the tank. Gallons in the tank after 20 minutes if we contained 800 gallons of water when the pump was turned on. So part of what we're going to do is we're going to integrate R of t dt. So remember that R of t is like what we would get after we take the derivative. So if I have R prime, R double prime, right? What did I take the derivative of to get R? Capital R. So we are looking for R of 20. That's what we want. That's what it's asking us for, big R of 20. That's what we don't know, which we'll find. And then we know it contained 800 gallons when it was turned on. So that means that is R of 0. No time has elapsed. And I have 800 gallons in there. Okay. Make sense? Well, I'm already started over once. Y'all should have walked faster. Okay. So that means I want R of 20, big R of 20. I started with R of 0. Oops. Started with R of 0. And then I'm going to integrate R of t dt. And that's going to go from 0 to 20. And since 0 is on the bottom, this is going to be addition. Does all that make sense? All right, so that means that my R of 20, if I was actually going to put this in the calculator, what is R of 0? 800 plus, and I would integrate from 0 to 20, that 30 times 1, 30 would help out with 0. 30 times 1 minus e to the negative 0.16 t dt. And then the calculator would do it for you. So one of the things that we are looking at today, as far as we're looking at it in context. If it says the amount of water contained in the tank, that means we're adding something or subtracting something here. If it asks us how much was added to the tank, that's when we're just looking at the accumulation. You see the difference there? Because we have to understand the difference in how we write them, like whether or not we're actually using that fundamental theorem or if we're just doing an integral. Okay? Ask me a question. Where did I get the 30? Right here. I just rewrote that. which really I could have just left it as this and it would be fine since it was identified as that. That's what you would type in your calculator. We good? All right, so let's look at the next one. The rate at which water is being pumped into the tank is R of t equals 20 e to the 0.02 t, where t is in minutes, R of t is in gallons per minute. Write the integral expression that would be used to determine how many gallons of water have been pumped into the tank in the first 5 minutes. I'm looking for how many gallons have been pumped into the tank. Am I adding or subtracting anything to this? No, this is not a snapshot. This is pure accumulation. How much has been added or how much has been taken out, which means there's no, it's just the integral. And we're first 5 minutes, so we're going from 0 to 5, right, of R of t dt. And that's it, right? Everybody good with that? Do you see why we didn't add or subtract anything? If it had said how much water is in the tank at t equals 5, that would be a whole different story. Okay? The fact that it said pumped into the tank, that's the amount of accumulation, that's the amount of change, that's why it's just the integral. Okay? We good with that? All right. Let's look at number 5. The rate at which ice is melting in a pond, okay, gives me this, where V is the volume, the ice in cubic feet, T is the time in minutes, so V is in cubic feet, T is time in minutes. Write an integral expression used to determine the amount of ice has melted in the first 3 minutes. Is this pure accumulation or is it a snapshot? Pure accumulation meaning, is pure accumulation just how much it has changed, or is it what is the volume of the ice at this time? It just said how much has melted, right? It's not asking for what is the volume of the pond, right? That's the way the volume's changing, has nothing to do with that. So that just means that it's an integral, first 3 minutes, 0 to 3. I don't know, my integral looks so weird. Integral from 0 to 3. And let's just write this one out. 1 plus e to the t dt. That's the amount it has changed, the amount of ice that has melted in the first 3 minutes. Everybody okay with that? Okay. Now let's look at number 6. It gives me all of this. We're going to write an expression to evaluate f of 2, okay? So in this case, I do need a snapshot. I want to know what f of 2 is, right? So f of 2 is equal to, then we got to use what we have. They gave me f of 3. All right, f of 3, right? Then I'm going to integrate my limits of integration. What goes down here? 2. What goes up here? 3. And just put them in there from least to greatest so that you have them correct. And this is up here at the top, so what goes here? Subtraction. And that would be of f prime of x dx. That would be acceptable, or you could actually put that in there where f prime of x is. Just make sure you would also include that dx. I do. Thank you. Okay. Let's read number 7. A tree has been transplanted after 2 years of growing. At this rate, after 2 years, it has reached a height of 5 feet. Write an equation containing an integral that would determine how tall the tree was when the tree was transplanted. Is this an accumulation or is this a snapshot? It's a snapshot. It's not how much did it grow, right? It's what is its height right now, or right whenever we're asking about. Since it's a snapshot, that's when we use that fundamental theorem, right? So let's think about what we have. So I'm going to call this f prime of x just so I have something to call it. Right? It has been transplanted after 2 years of growing. After 2 years, it has reached a height of 5 feet. So that would mean that f of 2 is equal to what? 5 feet. What are we looking for? F of 0. Okay, that's what I'm looking for. That's what it's asking for. Everybody understand how I came up with all that? So I want f of 0 equals, well, f of 2 I know, right? F of 2. And then I'm going to, in it, so it's that 5 feet, and I'm going to have to subtract off however much it grew, right? I have to figure out how much it grew. So this goes from 0 to 2 of 1 plus 1 over t plus 1 squared dt. Snapshot looks more like an equation. Just the accumulation is going to be more of an expression. Okay, everybody good with that? Okay. Spherical tank contains 81.637 gallons of water at t equals 0 minutes. For the next 6 minutes, the water flows out of the tank at this rate, gallons per minute. Write an equation containing an integral that would show how many gallons of water are in the tank at the end of t minutes. Okay? Not how much has been added or subtracted, but how much is in there. So that means that we know that, let's see, if we called this r of t, since it called it a rate, we can call it r of t, which means capital R of 0 when t equals 0, that's 81.637. Right? For the next 6 minutes, water flows out of the tank. Write an equation, an integral that would show how many gallons of water, and it just says the end of t minutes, so I want r of t. I don't know that it's 6. I mean, it says for the next 6 minutes, but it says write an equation containing the integral that would show, so like maybe I want an equation where I can figure it out at 4 minutes or 5 minutes because it's leaking out for 6 minutes, but we want to be able to figure out something from in there. So r of t is equal to r of 0, which we know, and then we're going to integrate, well, we're going to go from 0 to t or t to 0. What would make the most sense? 0 to t, because all the t's are going to be greater than that, right? So 0 to t, so this is plus, right? And then 9 times the sine of the square root of t plus 1 dt. So let's think about that. Let's think about this. It says for the next 6 minutes, water flows out of the tank at a rate. If a water flows out at a specific rate, is that rate positive or negative? So the water flow rate is negative. If it flows out at a certain rate, we'd say like it flows out at 5 gallons per minute or whatever it is. We wouldn't say it flows out at a negative 5 gallons per minute. Do you see the difference there? So the fact that it flows out of the tank at that rate, this is going to be a positive number, but what's actually happening to our water? We're getting less of it, right? So is this correct here? Based on the wording? No. What should we change? The plus. Even though we put the plus because it's down here, because of the wording that it's flowing out, this rate is positive. We can either make the rate negative or we can change this sign here, either way. But do you see the difference there? It's actually a negative rate. it flows out, so like it flows out at 5 gallons per minute. The water flow rate is negative 5 gallons per minute. Do you see the difference there? So you either change that or you change that when you reread it. Okay? What questions you got? Okay, so those of you that were here at the beginning, you can start working on that unless you want to listen to the beginning part of this again. Otherwise, we are going to, I'm going to start back over so I can talk through some things that the people came in late since we have time.